All right, let's look at a double replacement reaction. So we're going to take aqueous barium hydroxide and aqueous ammonium acetate and add them together. Now, if I'm not mistaken, my kids, this is number 33 on your homework, so it's a freebie. Now, what's going to happen? The potential products of this: barium, a cation, is going to try and bond with what thing from ammonium acetate? If you guessed ammonium, you are terribly mistaken, because ammonium is also a cation, and two cations are going to repel one another, so barium and ammonium are going to want nothing to do with one another. However, barium will be attracted to acetate. So the potential product there, now barium forms a 2+ charge, acetate forms a 1- charge, so the formula for barium acetate is going to be Ba parentheses CH3 CO2 2 plus, and then the other combination is going to be ammonium bonded to hydroxide. And since ammonium is a 1+ ion and hydroxide is a 1-, then it's just going to form NH4OH. Now the question we have to answer is, are barium and acetate more attracted to one another than they are to water? And are ammonium hydroxide more attracted to each other than they are to water? If either of these are insoluble, which means that they are more attracted to their partner ion than they are to the water molecules, then it'll form a solid and it'll precipitate out of the mixture. If not, if both of these are soluble, meaning that these ions are more attracted to the positive sides and negative sides of water molecules than they are to one another, then it's going to stay in solution and we're just going to end up with ion soup, a whole bunch of ions floating around together, but not bonding. So if you look at your solubility rules, so the first solubility rule is that all the alkali metals and ammonium and hydrogen ions are always soluble, no exceptions. And so that gets ammonium always soluble. So this guy is definitely aqueous. And if I'm not mistaken, your second solubility rule, the second one down, is that acetates are always soluble. And bam, barium with acetate, that's going to be soluble. So this guy also aqueous. So we could stop there, but I would like us to write out. So let's see. First, let's go back. It'd be nice to balance that reaction. And since there are 2 hydroxides, 1 hydroxide, 2 acetates, 1 acetate, we can balance this by putting a 2 here and a 2 there. 2 ammoniums, 2 ammoniums, 2 hydroxides, 2 hydroxides, 1 barium, 1 barium. Now the next thing we're going to do is we're going to write an ionic equation. So we are going to take all of these aqueous things and split them into their constituent ions. So we will have barium 2+ and 2 hydroxide ions plus 2 ammonium ions plus 2 acetate ions. I'm going to have to start writing a lot smaller. Makes a barium ion plus 2 acetate ions plus 2 ammonium ions plus 2 hydroxide ions. And then we can take this ionic equation and we can cancel out any ions that appear on both sides. And that's going to be something called your your overall ionic equation. And so our net ionic equation, so we've got a barium ion on each side, so that cancels. We've got hydroxide ions, 2 of them on each side, those cancel. We have 2 ammonium ions on each side, so those cancel. And we've got 2 acetate ions on each side, so they cancel. So our net ionic equation is zilch. We have nothing left over. So what did all of this make? Made a whole bunch of nothing. Just ions floating around, nothing bonded. And so we can ion soup. All right, just a whole bunch of ions floating around, but they didn't do any chemistry. Just made a mixture. So that is a no reaction type of double replacement.